Quantitative estimation of protein using biorate reagent, multi-standard calculation as well as graph is used. The reagents involved are biorate reagent, 0.1 normal NaOH, working standard of 200 milligram protein per 100 ml, 2 unknown concentrations of test 1 and test 2, 7 test tubes marked blank, S1 to S5 serial dilution of standards, then T1, T2, 2 unknown concentrations of protein solutions. We need glass pipettes, teats, and if you want to use micro pipettes are also can be used. Further, we need a water bath of 37 degrees Celsius, a colorimeter or a spectrophotometer if you have one. We start by adding different amounts of working standard 200 milligram per 100 ml of protein to S1, S2, S3, S4 and S5 in the order 0.2, 0.4, 0.6, 0.8 and 1 ml. Now this is followed by addition of the unknown concentrations test 1 and test 2. 1 ml each of test 1 is added to tube T1 and test 2 is added to tube T2. All the test tubes are made up to 2 ml using 0.1 normal NaOH. First of all, the blank test tube we add 2 ml of NaOH, then from S1 to S5 we add 1.8, 1.6, 1.4, 1.2 and 1 ml of 0.1 normal NaOH, and to the tubes marked T1 and T2 we add 1 ml each of the this particular solution, that is 0.1 normal NaOH, so that all the tubes will have exactly 2 ml of solutions in them. This is made up to 2 ml, all the test tubes, including the serial dilution of standards. Next, we add biorate reagent 3 ml to each of these test tubes. 3 ml of biorate reagent is added to blank from S1 to S5, T1 and T2, so that all the test tubes will have a total volume of 5 ml. The tubes are now incubated at 37 degrees Celsius for 10 minutes, and after 10 minutes the tubes are taken out and the solutions are read using a colorimeter. Now you can see the purple color developed in the tubes. I am showing here blank, S1, S5 and one of the tests also. Now we are doing the blanking of colorimeter. 1 ml of blank is added to a clean cuvette. 1 ml is the reading volume of colorimeters. Now this is wiped, the cuvette is wiped clean of any moisture that is important and inserted into the chamber, reading chamber of colorimeter. The machine is set at wavelength of 540 nanometers for doing biorate. Calibration is done by pressing 0 button, and now 0 calibration is done. Now we read all the solutions one by one, and any remnants of the previous solution is removed by tapping on the tissue paper. And 1 ml each of this S1 to S5, T1, T2 are read using the same procedure. We need not press any buttons on the colorimeter. The reading will automatically appear in the display. We can see that.
Here you can see the test tubes arranged for our standard curve. First, we will adjust the volume of our pipette to 0.2 milliliters. 200 microliters of protein will be added to the first tube. The process will then be repeated, adding twice as much protein to each subsequent tube for our standard curve. Note that our blank tube will not contain any protein. Water will now be added to each tube, including our blank. This will bring all tubes to the same volume, thereby creating a serial dilution of protein concentration. We will now add 5 milliliters of alkaline copper reagent to each tube. Each tube will be vortexed gently and then returned to the rack. Tubes will rest at room temperature for 10 minutes. Next, we will add 600 microliters of the Folin reagent to each tube. Immediately after adding, we will vortex the tubes once more. Tubes will rest for an additional 20 to 45 minutes at room temperature. The blank is transferred to a cuvette for our spectrophotometer and will be used to blank the instrument for subsequent readings. We will then read the absorbance of each tube in our standard curve. Note that we typically read the absorbance for this assay at 550 nanometers and not at 650 as shown in this simulation. In the end, you will have a table like this, which will go in your lab notebook, that has the absorbance values and volumes of each of the reagents. These can be used to generate a standard curve from which you can extrapolate the values for our unknown.
The advantage of this method is its high sensitivity and precision. The value is very accurate what we get from Lowry method. The disadvantage of this method is that it is not compatible with the detergent and reducing agent.
of test is that it's not affected by sucrose and other carbohydrates. It's also not affected by presence of ions like sodium and potassium. The disadvantage of breadfruit test is that it's affected by the presence of detergent. Also, the dye can non-specifically bind with amino acids like arginine and lysine.
So here are the steps for making your standard curve and finding the concentration of an unknown. You're going to make the standard solutions, then you're going to measure the absorbance of those solutions in the spectrophotometer. Then you're going to make a graph of concentration versus absorbance. That is called the standard curve. Then you're going to measure the absorbance of the unknown that you have, and then you're going to graph it and determine the concentration. So we're going to look at all 5 steps in an example here. So I make my standard solutions with different concentrations of the material that I am interested in. So I am adding the material to each of, in this case, I just picked 5 cuvettes. So I know what's in each one, right? Because I made them. I'm going to take each of those vials and I'm going to measure them in the spectrophotometer, and I'm going to graph absorbance. So now I have a table of concentration and absorbance for my proteins. And now all I have to do is graph them. And you can do this by eye if you're just doing a real quick version of this, or you can enter it into a computer and the computer will tell you the confidence of the line and how well the line, fits your data. But this is basically what you need. The standard curve is actually not a curve. You need to use the portion of the curve that is linear. That is a whole other discussion. But the standard curve is actually a line, okay? And if your data don't make a line, you can't use it. Okay, now this is the standard curve. This is your ruler. So this is the set of standards of known concentration. In other words, you know what the concentration in each tube is, and you know what the absorbance is. And so that's your ruler. So now when you have your unknown, this is step 4. You take your unknown and you put it in the spectrophotometer and you get the reading. And now you put that reading on the y-axis. So here I just happen to get 0.70. Now I put that on the y, I draw straight out a line until it hits my standard curve, and then I draw straight down from there until it hits the x-axis. And that value on the x is the concentration of my unknown.